Hello and welcome. Here's a recap, or rather a help file, for the practice of Newton's first law, force of gravity, and Newton's second law, where we are practicing how to draw a free body diagram and calculate several things. The very first example only requires one free body diagram. We have a box resting on a surface, and the forces that are applied to it are balancing each other out. The center of this object, I will have force of gravity going down and normal force that is opposite to gravity and equal in its length. So that is going to be force normal. Force of gravity equals normal force. Now the formula for gravity, remember, Fg is mg. Let's say the mass is 450 grams. So if you have 450 grams, you have to divide that by 1,000 to get to kilograms, and you have to go to kilograms because otherwise the force is not going to be measured in newtons, and we need it to be in newtons. So divide by 1,000, we get 0.45 kilograms. So then force of gravity is going to be 0.45 times 9.8. That should be 4.41. So I'm just going to say 4.4 newtons. And then normal force being equal to it is also 4.4 newtons. B will refer to the same free body diagram. Normal force still equals gravity, and I'm suggesting you give yourself gravity. A different number, not the same as you did before. So let's say force of gravity, I'm just going to choose 520 newtons. Then mass from there, if mg equals 520, then m is going to be 520 divided by 9.8, 53. So that's the mass. Then normal force, again, equals force of gravity, so it's also 520. And then C, again, one more time, we use the same diagram, still works. Gravity and normal are the same. Let's say my normal is 640 newtons. Then force of gravity is 640 newtons because they're equal and opposite, from where mass is going to be 640 divided by 9.8, 65 kilos. There you go. So that is problem 1. If you look at the description of the exercise, there's a link where you can plug in the numbers. Just make sure you make a copy of that. You can plug in the numbers and see if your answers are correct. Now we're going to move on to problem 2. Problem 2 is about a skydiver, so we will have force of air resistance and force of gravity, and scenarios are different. I'm going to start not with A, but with B and C, and I'm going to run them in contrast with each other. In B, I'm saying that the acceleration is downward. If the acceleration is downward, then my force of gravity should be greater than the air resistance. So that is the free body diagram, gravity, air. If, however, the acceleration is upward, that means that force of air exceeds force of gravity, like so. We have our free body diagrams. Boom. I'm going to work with the first one for case B, and I'm going to say 720 newtons is my force of gravity. Automatically, you know, if that's gravity, then your force of gravity 720 divided by 9.8 would get you 73 kilograms, which is mass. So if force of gravity equals 720 and it's greater, I still need to give myself acceleration. It needs to be less than 9.8, and needs to be less than 9.8 because if it's greater than 9.8, then air resistance is actually helping you to fall, which is impossible. So let's say it's falling with 5.2 meters per second squared. Because there's acceleration, we're going to resort to Newton's second law. Net force equals mass times acceleration. Net force in our case, gravity, minus air equals mass times acceleration. So gravity decided was 720 minus force of air, which we are looking for, equals 73 times 5.2. So air is going to be less than 720 by the amount of the net force. So go ahead, use your calculator for your numbers. Remember, do not repeat mine. Please use your own. I got force of air for me, so mass is 73 kilograms. And force of air is 340 newtons. Let's say the mass for the object is 41 kilograms. By definition, 41 times 9.8 should be force of gravity. So I got force of gravity to be 402 when I round it up. Let's say it's accelerating upwards with 3.6 meters per second squared. So then, again, it's net force equals mass times acceleration. The difference now is net force is air, which is greater, minus force of gravity. That's your upward acceleration because that's your upward net force equals mass times acceleration. So mass, we said, is 41, acceleration is 3.6, force of gravity is 402, force of air here minus 402. So then force of air is going to be 402 plus 41 times 3.6. Again, where you are using your own numbers, but the steps are the same. So for me, 550 newtons. There you go. The first one, the actual A, 64 kilograms, and force of air, I'm going to solve both. I'm going to take a small force of air like 120, 1200 for example. Okay. In this case, I have gravity greater than air, so I'm going to say 64 times 9.8 for gravity, that's force of gravity, minus air equals 64 times acceleration. Force of air, I said, was 120, so then 64, 9.8 minus 120 gets me 507. So 507 equals 64 times A, where A is then 507 over 64. 7.9 meters per second squared, and that's going to be downward because force of gravity is greater than force of air resistance. If I go for the second case, what was our force of gravity? 64 times 9.8, 627. So 627 newtons of gravity against 1200 newtons of force of air resistance. My net force in this case is going to be air minus gravity, 1200 minus 627, 573. So then 573 for net force divided by 64. That's going to be 8.95. So 9 meters per second squared upward. Problem 3 is about an object on the desk, and again here I can just draw one free body diagram. So that's going to be Newton's first law for these. That net force in the vertical direction is 0, they're balanced. But in the horizontal direction, we have these two forces, and pull is greater than friction. Let's say mass is 5 kilograms, force of pull is 25 newtons, force of friction is 12. Net force is 25 minus 12, which is 13 newtons, and then we have our acceleration, which is net force divided by mass, 13 divided by 5, 2.6, and that's going to be meters per second squared. In the next example, again, I'm going to have mass, let's say it's 12 kilograms, force of pull, let's do 150, and I'm going to say acceleration is 3 meters per second squared, and now I need to find force of friction. Setup is the same. Net force equals mass times acceleration. Net force being force of pull minus force of friction equals mass times acceleration. So I gave myself 150 for pull minus force of friction, which I need to find, equals 12 for mass, 3 for acceleration. Then force of friction is going to be 150 minus 36, 114 newtons. And then the very last one where we have to figure out the force of pull, we kind of had an example like that, but just for practice. The more you do it, the better you get at it. Let's say it's a 25 kilogram box with force of friction of 120 newtons. Acceleration will be 4 meters per second squared. Figure out force of pull. Net force equals mass times acceleration. That is pull minus friction equals mass times acceleration. Force of pull is my question mark. I need to figure that out. Minus 120 equals 25 times 4. So that's 100. And then from there, force of pull is going to be 100 plus 120, 220 newtons. And there you go. I hope this was helpful and you are getting better at these types of problems. I'll see you in class.